Hi, Professor. My name is Dat, and my student ID is TD511. And today I'll be represent for presenting my final project for our final project where we build a like production grade and multi-environment AWS infrastructure using Terraform. So the project delivers like separate depth staging prod environments, uh, an application load balancer, and also an auto scaling group, and S3 static content, and a fully automated deployment using Terraform modules, and also high availability with self-healing capabilities. So the next one, I will demonstrate the setup, explain the traffic flows, show working infrastructure, and perform a lift failover test to prove high availability. So the next one, let me just start the structure of our Terraform project. So here you can see that this is the uh, infrastructure code. So we follow best practice by using module folders, and networking security ALB, ASG launch template. You can all see here. So the environment folder. So this is the environment folder. Let me just close all of this to we can see easily. So this is the environment folders and depth and staging and prod. The provider TF and backend TF configure per environment. So the variables plus outputs clean separation of configure and logic. So the key point is that we wrote Terraform once and but reuse module across all the environments. So this ensure that about like the consistency and also the repeatability, and also the lower risk of misconfiguration. So for example, this is our networking model. Mm, So this is our networking model is create like the VPC, is create like the VPC and public private subnets, internet gateway, and also NAT gateway, and also route table and subnet association. All is like reusable and like parameterized by variables. So let me just open the dev main TF. Yep. So this is the main dev deployment. It calls all the modules with environment specific values. So I already run all the command here to run and deployment on AWS service. Um, Here you can see here I already run it by Terraform Uplive, and this shows Terraform successfully builds the dev environment, and also I did the same for the staking and also the prod one. But to run it again, it's like takes so much time, so I just take the dev environment to represent it. So the third part is like the traffic flow explanation. The flow explanation. So the blue flow is like the end user web traffic runtime phase. So this flow happens during like normal operation when end user visit our website and user send HTTP request to the application load balancer, and the ALB perform health checks, then forward traffic only to healthy EC2 web servers in private subnet inside auto scaling group. And this is typical web traffic is not administrative. It's a real user interaction with the system, and if any instance become unhealthy, and so the ARB automatically reroute traffic, ensure uninterrupted service. And moving to like the red flow, this flow occurs when developer push new code or infrastructure updates, and developers commit to GitHub, and GitHub Action performs security checks, and also moving to like the Terraform code is deployed, and the last one is AWS infrastructure is update, and this is administrative traffic triggered by team member or like CI/CD tools. So the last one is the gray flow. Like this flow automatically when new EC2 instant launch inside onto scaling group. On boot, like each instant run user data dot sh, which download website content from S3 bucket like index.html and or like image folder. And this is like the infrastructure is initialization traffic. No human trigger it like the auto scaling group and easy to handle it automatically. So let me move into the S3 content. Um, so the next one S3 content plus issue user data. So is our S3 bucket storing website content include index HTML and an image. So this is like the index HTML, and you will see that whenever easy to launch it, install a patch, download content from S3 and serve it through via HTML, and please ensure all the web server are identical, supporting scaling and replacement. So the fifth part is like the application load balancer plus healthy target. Let me just move to the EC2 right here. So here's an application load balancer created with Terraform. So this is the like like this DNS name shows that the web being served by EC2 instant. Like in the target group, you can see that. So let's move to the target group. So here you can see all the register instance, both healthy and meaning ALB successfully perform health checks and forward traffic. And when I paste the URL links into the new tab right here, it shows up the group environment right here. Um, so like the next one is a rational why we're not using ASG and ALB. Like we use auto scaling group with load balancer for three reasons. Like the first one is high availability. If one instance fails, ALB removes it and forward traffic only to healthy one. And second, secondly, like ASG can scale out during high load and scale it into like save the cost. The third one is like self-healing, while ASG automatically replace failed instance, maintaining the design capacity. And this also is a core AWS production button used in like a real company. Uh, s- okay, so the next one is high availability lib failover test. So you can see here we got two instance right here, and two instance are stopping traffic behind ALB. And when we just need to stop the instant, if we stop the instant, like I am intentionally stopping one server to simulate a failure, and you can see when we stop it, the target group will become unhealthy. And when refresh ARB DNS, the website continue working with zero downtime, and ARB automatically reroute traffic to the remaining healthy server. And also, AS is self-link, like auto-scaling group detect the failure and launch replacement instant to maintain capacity. And this prove our solution is like highly available and fault tolerant and self-healing. So the last one is of challenges and the learn the lesson that we've been through. So in this assignment, I faced several challenges. Like the first one is the S3 permission issue, and like the public access blocking and policy. And the second one is IAM restriction in the AWS Academy environment, and also like ALB health check return like the 502 errors initially, and user data timing issue, and also like the Terraform state separation per environment. And for solving this, for solving all of it by applying like AWS documentation, structural debugging, and incremental testing. So, that I learned a lot about the project grade design patterns and AWS infrastructure automation. So this concludes my presentation. I demonstrate environment deployment, ALB, ASG, and S3 integration, traffic flow, and high viability through of live failure tests. So thank you very much.